Yeah, I'm in the physics department at Hamilton College, which is a small liberal arts college in upstate New York. It's nice to be here. And today I'm telling you about the Planet 9 hypothesis, a simple modification of gravity called MOND, and some science that we can do with Breakthrough Starshot. So starting with the Planet 9 hypothesis, this is the idea that there could be a fairly large ninth planet lurking out in the far reaches of the solar system. So of course, Pluto used to be the ninth planet. It was demoted back 15 years ago or so. It's now considered a dwarf planet. And it occupies, it lives out in a region of the solar system called the Kuiper Belt. So Pluto's orbit is on average about 40 astronomical units from the sun. This is in the Kuiper Belt region where there are many of these small icy planetesimals. And the motion of some of these Kuiper Belt objects has become interesting recently because there are 6 objects that have orbits that are clustered in both physical space and parameter space. And the clustering can be explained through the presence of a fairly large planet, about 5 to 10 times the mass of Earth, located at about 500 astronomical units. So the idea is that the ninth planet, Planet 9, is gravitationally interacting with some of these Kuiper Belt objects and drawing their orbits into this sort of clustered configuration. So this is this is observed and the basis for the Planet 9 hypothesis. Now, there's another way to explain this clustering, which is in the context of a theory of modified gravity called MOND, which stands for Modified Newtonian Dynamics. And MOND was developed in the early 1980s to address properties of galactic rotation curves. The galactic rotation curves are now understood in the context of dark matter. And as a cosmologist, I think that there's good reasons to believe that dark matter exists. But we've been looking for it for a long time, and we still haven't found direct evidence for it. So until we do, it's worth considering alternatives, and MOND is a sort of alternative to dark matter. It's a simple modification of just the Newtonian gravitational field. So in MOND, there is no dark matter. There's just ordinary baryonic matter and Newtonian gravity, which is modified by something called an interpolating function. So the core idea at the heart of MOND is that there's a fundamental acceleration scale, which is 10 to the minus 12 meters per second squared. And when the Newtonian gravitational acceleration is comparable to this scale is when MOND predicts deviations from Newtonian behavior. So you can take the mass of the sun and ask at what distance do we expect, or do we find that the sun's gravitational acceleration is comparable to the MOND scale, and that distance is about 7,000 astronomical units, which is in the Kuiper Belt Oort cloud region where these planetesimals are. So that suggests that there should be evidence of MOND or deviations from Newtonian gravity that are predicted by MOND out in this region. You can understand the effects of MOND in terms of something called a phantom mass. And so this isn't a real mass, but it's just a mathematical term that can be interpreted as mass. And we show that the distribution of phantom mass in the outer solar system is actually peaked right in this region. This is where I wanted to use the laser. But it's peaked. This is sort of the bright yellow color on this plot is the peak of the phantom mass distribution. This lies right around the 1000 AU region of the outer Kuiper Belt inner Oort cloud. So we expect some action here from MOND. Additionally, in the orbital phase space of the Kuiper Belt objects, MOND predicts a fixed point in the evolution of the orbit of certain Kuiper Belt objects that would essentially draw objects into this region of parameter space. So MOND predicts that Kuiper Belt objects should be living in this fixed point. And physically, it has to do with the direction of the galactic center. This is a special direction within MOND. So there should be a preference for orientation towards the galactic center of certain Kuiper Belt objects. And when we overlay the direction of the galactic center on the orbits of the same 6 Kuiper Belt objects that are used to establish the Planet 9 hypothesis, the alignment is quite good. In fact, statistically, it's very good. And so MOND is as good at explaining the data that are used to support the Planet 9 hypothesis as Planet 9 is. And with my remaining few seconds here, I'll just briefly mention Breakthrough Starshot. So a couple of people have talked about this yesterday, but part of the Breakthrough initiatives is the idea of launching a very small space probe called Starshot with the intention of traveling to the nearest star. But Breakthrough Starshot could also do some science along the way. And one of the things that it could do is look for effects of MOND, because MOND should have signatures in the outer solar system. So by launching one of these small probes, the velocity of the probe would be different in MOND than in Newtonian gravity. So just by tracking the velocity, you could see if there's any effects of MOND. And I'm out of time, so thank you.